Hello there, this is Pilker10 and welcome to your fourth, I believe, RBX.lua intermediate tutorial. Let me just check if it's actually fourth. It is the fourth. Welcome to your fourth RBX.lua intermediate tutorial. Now this one is going to be focusing on more of the practical aspects of object-oriented programming. So, previously, we sort of learnt how to use a bit of object-oriented program. We know how to create the class, so we know how to use methods with it, like we have used meta tables and meta methods, but we haven't really put it in any sort of practical situation yet. Today, that's what we're going to be doing, and I've reasoned that the simplest way I can show you this, while still being actually useful for a Roblox game, is to create a brick. Now, this brick is going to have behavior. It's going to be like one of those bricks in the those grow your brick places that I've seen on Roblox before, and I ended up playing one a while ago for some reason. It's a stupid idea, but it seems to work. Anyway, the first thing I'm going to do is just delete some of this old code, because I don't need this. We're just going to leave that with return object key for now. We're going to delete all this as well, and this, and this. We're also going to create a table called objects, and I'll explain that now. So, what we're going to do is, when we're creating new objects and new objects and new objects, we want a way to store this information. Now, there isn't any way of storing all the new objects without putting them in a table. So if we were going to create this object, we want it to have all of them stored, so that for a good reason, and that reason will become obvious later on. And Trappy Notes said yes, so I'm going to move to the AFK channel. My taskbar goes away. Okay, good. So the first thing we're just going to do is just give object of the brick a number of properties. For example, o.part equals vector. No. So what am I doing? This is going to be a standard part, and it's going to automatically parent to a workspace. Now this is going to take one argument position, because we want it to start with position. o.part.position equals position. Now there's also another thing that we're going to need to do with this index meta method. We don't want the object's part to be able to change from something else. We want to be able to change the part. So what we're going to do here is, whereas I'm going, instead of having just a normal part property, we're going to have an underscore part. We don't want any script to be able to change this part. So, we're going to make it read-only. It's not going to be completely foolproof read-only, but we don't need that. We need to know that if we change it, we don't want it to be changed. And the reason for this is if we accidentally end up setting the part for something, then we'll want to know exactly what the error is doing. So, we can easily debug it if we accidentally do it later on. So we're going to make the underscore and then part in caps, which means whenever we try and set it to something, with this, if let's see, if key is part, then we're going to error part. Actually, no, we're not. We're just going to go. First of all, we're just going to print error. So then we know what's going on. And this index, instead of just returning object key, because that's also is always a terrible idea, or if we want to make this non-read only, because then we'll never be able to access it unless we type underscore part. We're going to go if key equals part, then return tab dot underscore part. So effectively, this means that whenever the part essentially is going to be a variable that's just not actually a variable. So if we type object.part, it's going to return this. If we type object.part equals something, it's going to say part is read-only. And so that's all fine and done with now. We're also going to give it another variable, and this is also going to be a read-only variable, because we don't want anyone to be able to change this at all. And this is going to be the ID. There's a good reason why I'm going to call it the ID. Actually, I'm going to call it underscore n equal, and I'll set it to a value soon, but for now we're just going to leave it 0, and we're going to just do exactly the same thing we did with this. So we can't set it, and else if key is ID, then return tab underscore ID. So the reason that we need this thing. Now n is going to be the position of the object in the table, and there's still a good reason for that. I'll explain later. But what we're going to be doing straight away is having a way of just quickly creating the object and putting it in the table without having to go object.new, create a position and increase the ID and then put it in the table. And also in the future we may want additional things to be done every time we create the object. So say we wanted to create 5 other objects when we create this object. This function will be very useful for that. And this function is just going to be simply create object. So this is going to do everything we need. So just to start with, a position of the object. So this is just going to go. It's going to create an object like this. It's going to insert the object into the table. It's going to insert the object table like yes, like this. And what's the table called? Objects. O. And now we're going to set the ID of the object. So the object knows what position it is in the table. Now that's actually something we're going to do before this, so we're not going to actually do this. Sorry, that was my mistake. We're going to add another variable here. So this is going to be n. So n equals n. This is going to first of all find out n. So local n equals. Now the n, we want, as I said, we want to know what position it's going to be in this table. So this is going to be the length of the table add 1. So that's the position it's going to be. So the length of the table, say it's got 5 objects in it, we're going to put it in the 6th position. It's going to get the length of the table, which is 5, add 1, which is 6. So it's going to end up in the 6th position. So we're going to create this here, and then m. So now the object knows that it is the 6th position in the table. We're not going to use table. We're not going to use table.insert. We're just going to use this method. Objects n equals o. So that's going to set objects number 6 equals o. End. And now the reason we're going to do this way is so that the object can be easily removed from the table. You may say, well, you can do that anyway with table.remove, but can you? Table.remove works this way. Table.remove. The first argument is obviously the table, but the second one is to position in the table which it is. Do we know the position in the table if we didn't have this ID variable? No. So we actually need to keep the position of this table with the ID, because otherwise if we wanted to remove something from the table and then we wouldn't know where to remove it from, we'd have to loop through every object in the table, which is really inefficient. You could be looping through hundreds of things if you've got hundreds of objects, and then it would just match up each one and then finally delete the one when it gets to there. But there's also a reason we don't want to use table.remove either. And the reason for that is this shifts everything down. So say we have a table which is, say this is a test table, is there's 9 objects in this table. If we remove the 4th one, then this is going to happen. It's going to with table.removed, all of these ones are going to be shifted down. So number 5 is no longer the 5th one in the table. We really don't want to do that. And the reason we don't want to do that is because the position that they think they're in the table, their value, we don't have to change every single value of n in every single object every time we remove an object, which could be a lot of the time if a lot of them are being removed for whatever reason. So we don't want to have to do that. So instead, whenever we're removing an object, we're just going to set it to nil. instead of 1, 2, 3, 5, and then the fifth one is actually going to be the fourth one, the sixth one will be the fifth one, the seventh one will be the seventh one. We don't want that to happen. Instead, we're just going to change the one in the table to nil. So 1, 2, 3, nil, 5, 6, 7, 8. So the 5 is still the fifth one in the table, and the 6 is still the sixth one in the table. But this object still doesn't exist. This object is still nil. So that's how our removing system is going to work. And so for this, we're just going to go function remove objects n. And this is the easiest thing. Objects n equals nil. So hopefully you've understood this so far. I'll just go through it quickly again. What we're going to do is create an object and put it inside this objects table. This object is going, first of all, n is going to get the length of the table. So at the moment this is 0, so 0 add 1 is 1. O is going to create a new object at this position at n. I should probably give an example for this. So local O equals object new 0, 0. So object, we don't know. Well, sorry, that's a mistake. That might confuse people if I'd done that. Create object 0, 0. Create object function is going to go here. This is going to get the length of the table, which is currently 0, plus 1. So we're going to n is now going to be 1. O is going to create object.new at position 0, 0 and n 1. So here it's going to create a part at that position in workspace. It's going to and set this variable parts to that. It's going to set its n value to n, which means it knows what position it is in the table. So n is actually 1 at the moment. Then it's going to return this object, goes back here, objects, which is this table, and it's going to set the nth value of that, so that position, which is going to be 1 in this situation, to the object. So now this object table is going to look like this object. So this object table is going to have another table in it, which is going to be part and n, for example, something like that. And so then if I created another object, so part equals some part in workspace, that says, this is just an example though, this doesn't actually have, this text doesn't appear or anything. If you still think that, go back and watch the third tutorial. N equals 3. Local O2 equals create, oops. So if I did this, then this is going to create a second object. Why is that n equals 3? N equals 1. So this object is going to go here. It's going to get the length of objects, which is now 1, add 1 is 2. It's going to do exactly the same thing and create another part, this time at position 5, 5, and set the second element in that table to that. And it's going to go second because the length of the object is 1 plus 1, which is 2. So, 2. The second one is going to be like another part equal, it's going to be another table which is going to be like that, except n is going to equal 2. Now that's a key part. So let's just test if this works first of all. We're going to just look at that, see what's going to happen, see if we've made any errors. Got one part here and another part. Where is this part? How do you... this one? No, we've only got one part. So, position is not a valid member of part. Now that would be because... oops. I'm just going to lock this... oh no, it's already locked. The position is actually a capital letter in this situation. So we're going to create here. Vector 3 expected got number. So we've created one here, something else is broken. But that's because we typed 5, 5 instead of vector 3.new. I did it here as well. Vector 3.new 0, 0, 0. Vector 3.new 5, 0, 5. Let's do that. And by the way, the reason that it created one brick and then stopped working was because it went through this line, created the part in the workspace, then it broke on this line. So it's created the part, hasn't set its position, breaks, so it doesn't create any more parts. We're going to do this, and now it's going to create two of them without erroring. So now we have two parts, each at different positions. So that's a basic thing. But now we want to make them have behaviour. Now to make them have behaviour, we're going to need to track all of the object's progress every frame. Now, by frame, I mean it may be easier to understand it as ticks. Every tick on Roblox, or frame, in physics terms, is 0.03 seconds. That's 30 a second. 30 physics frames a second. This means that when we're going to be creating ours, that's how fast our objects are going to update. Now, you understand what update means once I've explained this more to you. I'm going to create an update function. And that's just dt. Now dt stands for delta time. And end it here. We're going to just create a for loop here. Let's just do a while to-do loop for now. We're going to loop through everything in objects, every single frame is going to be here. So this while to loop is going to go on forever. We're going to loop through everything in objects forever. So we're going to call the v update function. Now delta time, bear with me here, I'll explain it in a second. Delta time is the length of the frame. So I'll add that in a second. Why is it automatically untab here? Oh, I forgot to put a do on the end of this line, that's why. So the way we need to get the length of the frame is, so this is every single time this loop runs, everything in object is going to have this updated on them, and then obviously we need to wait, otherwise the Roblox loop will crash. It's going to do that every single time. It's going to go through here, loop everything, wait, and this wait means it's going to make them wait the minimum amount, which the minimum amount is always going to be one frame. One frame is probably going to be 0.03 seconds. That's 30 a second again. So it's going to wait 30 seconds, then run all of this again, then 30 seconds, then run all this again. And so this delta time, which is how long since the last update, the time it took since the last update, is probably going to be 0.03 most of the time. But as you can see, if I print wait 0.04, 0.036, 0.035, it's doing this every single time. As you can see, it changes slightly. So it can't just assume dt is always going to be 0.03. We have to actually calculate how long it was since the last time it updated. So we're going to have this local t equals tick. Now tick gets the current time in Unix. Now Unix is Unix time is the amount of seconds passed since January the 1st, 1972, I think it was. Let's just check that. Unix time is the amount of seconds, well, 1970, 1st of January 1970, not counting leap seconds. So this is the amount of time. This also means, by the way, you can calculate what day it is, you can calculate what season it is if you just use the maths correctly. You can calculate, you can do like special day events on your place, or the special seasonal events which would automatically happen when it turns to a certain time or a certain season if you use this time correctly. But for now we're just going to use it to keep the time. So it's going to create tick, which is going to be the, so look, for example, if I went back in here and print tick, that's the amount of seconds that have passed since 1st of January 1970. So we're going to go back here and create another one here. Old equals tick. Local dt equals tick, which is the new value, take away the old. So what's going to happen here? This is going to set it to the amount of seconds. So say 1 second has passed. It's going to be like a million seconds, or a lot more than a million seconds since 1970. So let's say 1 second since 1970. Then it's going to update this blah 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 first of all, we're going to need to just set an old before this. And we're not going to have this as a local variable, as you may be aware, because that old won't exist if this is a local variable. The next time it runs the loop, old will have been destroyed, and then old will be nil and will crash. Equals tick. So let's assume it's already done one frame. So the second frame, say old is 0. T is going to be 1 second, so 1 second has passed. So our delta time is 1 take away 0. That means it's 1 second since the last update. Now, once everything's updated, old is going to be set to whatever the time is now. So say the time is 1.1 second now. It took 0.1 second to update everything here. And now it's going to wait a frame. So old is 1.1. It's going to wait. It's going to go back here. So now T, say it is 1.5. Say it took that long. Say it took like 0.4 seconds to update. T is now going to be 1.5. So dt is going to be 1.5 take away 1.1, which is going to be 0.4. So that's how long the frame lasted. So this is how long we're going to see for delta time. So that's how long each frame lasts. Now I'm going to explain what the object function is and what its purpose is in object-oriented programming. The update function is used in every single game that is object-oriented and based around these updates, which is most things. In every game I've created, it has been almost everyone's games will be created this. Basically, the way object-oriented games work. By the way, this isn't just on Roblox. This is everywhere, every game. Every object will be updated every frame it's needed to be updated. Well, obviously there'll be optimizations. For example, on Minecraft, an object which is miles away from anything isn't going to be updated, because if all of those objects were updated every single frame, and then it would lag your game horribly. But obviously optimization. So every single time, every single frame, all of these objects are updated. Now this update function will do everything. It will move the object, it will sort collisions, it will do all of that stuff. It's just going to be the central part where it calls all of the other functions. Say in Minecraft, the first is going to update a pig. The pig will move 0.0001 in that one frame. It's going to update again, it's going to move that again. Update again, move that again. This is going to happen every single frame. So your Minecraft pig is actually going to move fairly quickly because it's happening at this amount of frames. So it's going to move this amount every single frame, and then it's going to hit something, and then the update function is going to check for collisions, and if it detects a collision, then the update function is going to call something else, which will resolve the collision. For example, if collision is I don't know, wolf, then wolf will eat it, or however things work. But that's the kind of way that every game works. On Call of Duty, you'll it'll say, your update function will say, for example, if player is holding W key, then move forward 0.01, and it'll do that every single frame and move that every single frame. So this is how games work. Now you may be wondering, well, what if you have a really low frame spec, and what if you're lagging and you've got a terrible computer and you're somehow running Call of Duty at 10 frames per second? Somehow that may be possible if you are playing on a toaster. Your frames per second is going to be a lot lower, which means you're going to update a lot less. Now there are two ways of doing this. One of them, well I'd explain doing what. If you update the object less, and you're moving the object, so say you're moving it one every frame. Every time you update it, you're moving it 1. The person with the fast computer who's running at 60 frames per second is going to move it at 60 times every second. The person who's running his computer at 20 frames a second is only going to move it 20 times every second. So the person with a faster computer, his guy's going to run faster. There are two ways you can solve this problem. One way is complicated, I'm not going to go into it now, is by separating rendering and physics. So we're not going to do that now, and I'm not going to go into that now. The second way, which is a lot easier, is by using this thing called delta time. Now delta time is what we've gone here, it takes the last time, and is going to times the movement of the object by the length of the frame. And this may sound odd, but for example, say, play. This is a Call of Duty game. Let's just no, that's not how you do block comments in Lua. Say this is a card game. Picker 10 has the Uber PC, so he's running at 60 frames per second. Zalduk has a crappy PC, so he's running at 10 frames per second. Every single frame I'm gonna update, so, and every single time, so you move one per frame per update. You update once per frame. So if I'm moving one per update and updating once per frame, this means I'm going to this time every single second I'm going to move 60 every second. Zalduk is going to move 10 every second. Now, I'm going to move a lot faster than Zalduk just because I have a powerful computer. Now, while you may say, well, you paid more, so you get the advantages. This is not how you want people to play a game. So we want actually for us both to be moving at the same speed. So because I'm running at 60 frames a second, the length of those frames are going to be a lot shorter. The frame time is going to be a lot shorter. If I'm running at 60 frames per second, the frame time is going to be 1 divided by 60. That's how long my frame time is going to be. So if I'm going to run 60 every single second, so that is actually 0.01 equals length of picker 10 frame. Zalduk is going to be 1 divided by 10, which is actually 0. Well, this is not 0.01, it's going to be 0.066. It's going to be 0.1, which is length of Zalduk frame. By the way, Zalduk genuinely does have a bad computer. I play League of Legends and it takes an hour for him to load each game. Well, this means Zalduk's frame is going to be a lot longer than mine because his computer's crap. So every single frame, we're going to say I move 1 per frame. If I times my 1 per frame, 1 times 0.0166 equals 0.0166. And say Zalduk moves 1 times 0.1, which is how much you want to move, times this amount will equal 0.1. Obviously, I'm just choosing the easy example of it being 1. It could be any number. It could be 13. It would be 13 times 0.06, and it would still work the same way. So this is how much picker 10 moves every frame. Zalduk moves. Whoops. Zalduk. Well, actually, I haven't explained this yet, so let's just delete this text here. So this means that if I move 0.0166 60 times a second, so if I go 0.0166 60 times a second, because that's how many frames I have, then that's going to equal 1. So that's how much I'm going to move in a second. If Zalduk moves 0.1 60 times a second, that's also going to equal 1. So you see, by timesing the frame time by the speed, we're both going to end up going exactly the same speed, even though our computers are different speeds and we're going to have different amount of frames a second. So this is going to make us both move 1 a second. Now you'll notice that this is significantly slower than it was before. Where first we're going to move 1 per frame. So I was moving 60, Zalduk was 10 every frame. Now we've done this, we're both moving the same speed, but we're both moving at 1 every second. That's incredibly slow. So we'll probably end up timesing this for something like 10. So I'll show you one more example to say all this is still the same, but this time picker 10. This time let's keep this bit all this bit all the same. I'll leave that there for now. This time I want to move my speed. I want my speed to be like 15, for example. 15 equals speed. So we're going to have 15 times 0.0166 equals, let's just do that on a calculator. 15 times 0.0166 recurring 0.25. Zalduk's going to be also moving 15 times 0.1 is going to be 1.5. Sorry, I was just answering a message there. Now, if I move 0.25 60 times a second, because that's how much my frame time is, that is going to be 15. Oops, what did I just delete? 15. If Zalduk moves 1.5 10 times a second, that's also going to be 15. So you see how we're moving now exactly the same speed, even though we're moving at different frame times, different speeds, different frame times, yes. So we're going to just implement that now. So no matter how badly the game's lagging, you're always going to move at exactly the same speed. Let's get this here. So we're coming to the end of this tutorial, but what I'm actually going to do now, yes, as I said, is just make the object move forward every frame. This isn't going to be the final behaving object, I'm just going to show you just how you can get this to work. So every time we update, we're going to move 0 or self dot part. Well, first of all, we're going to give it a speed property, by the way. O dot speed, say the speed is going to be 10. Part dot. We don't actually need to do that. We just, because it's read only, we just do this part dot position. Because remember of this, we can just access it with part equals self dot part dot position plus. Now you may have noticed that the speed is a number. It's a one number which we call a scalar. This means that that scalar means number, but as we can be moving in multiple directions, we don't have to be moving forward on the X, for example. When we actually make our game, the speed will be 10, but we actually need to move it by a direction, a vector 3 value as a velocity, but we'll go into that later. This is just showing you how to move things basically. Plus vector 3 dot new. Let's look. Let's make it go 5. Oops, what am I talking about? We want to go self dot speed times delta time 0, 0. Oh, actually, we're also going to anchor this part. 0 dot part dot anchored equals true. That means it won't just fall over anything. But then we want to create it slightly higher up, actually. Let's create it 5 height. Okay, so that's going to move that much every frame. So, let's see if you broke anything first of all. I'll see if it works. Unfinished long comment. As you can see, these now are both flying, because we've set them to 5 and anchored, and moving along at 5. 5, what would you know? Was it 50? No, it was 10 every second. So now let's just test. So hang on, let's just do a basic timing here. Let's get a stopwatch. Let's do this the old-fashioned way and get a stopwatch. Gonna time the stopwatch and let's see how. I'll bring the stopwatch onto this screen. Stopwatch count up and start. I'm going to time how long they take to get to the end. long is it going to take to get to the end of here? And stop. So that was 20 seconds, pretty much exactly. Now we're going to go back, and this time we're going to forcibly make it laggy. So rather than waiting the minimum amount, we're going to make it wait 2 seconds every frame. So this is if you're lagging horribly and every frame is 2 seconds, that's horrible lag. So let's see if we move the same speed. So we've got 20 seconds here. So just clear this and start. See what's happening here? It's taking bigger jumps because we've lagged it. It's going to get eventually. Imagine this will still move at the same speed. Stop. Exactly the same time as before. Even though it's lagging. And a completely different frame rate, it's still 20 seconds exactly. So that's all we're going to be covering in this scripting tutorial. In the next tutorial we'll be giving them more unique behaviour. We're going to be showing you how to create lots of stuff. But for now this is all we're going to be doing. We now know basically how every game ever designed works in object-oriented programming. And I'll see you in the next tutorial.